Hi. In this video, we are going to look at two problems in differential calculus. So problem 98 starts off with saying number of integral values of k for which the equation 2x power 5 minus 5x square plus k equals 0 has three distinct real roots and two imaginary roots is what? So we have to find the number of possible integer values of k for which this equation has three distinct real roots and two imaginary roots, right? Okay. So let's try to analyze this equation. We can write this equation 2x power 5 minus 5x squared plus k equals 0 also as k equals 5x squared minus 2x power 5, right? So let's think of it using graphs. So left hand side will be the graph of my function y is equal to k, and right hand side will be graph of y is equal to fx, where f of x is going to be basically 5x squared minus 2x power 5, right? And we have to see how many points of intersection we can find in y is equal to k and the graph of f of x, right? Number of intersections will give us the solutions. So the main idea here is to try to draw the graph of f of x. Graph of 5x squared minus 2x power 5, right? You should clearly see that the graph passes through 0. And you can see that x square is common and you have 5 minus 2x cube. So there is a repeated root at 0. Repeated root at x is equal to 0. And this is basically the graph of a cubic function. And you should realize that there will be basically one real and two imaginary roots here for the cubic, right? So the overall equation you can clearly see has three roots. The roots are 0, 0, three real roots, and 5 by 2 to the power 1 by 3. And the other roots are two imaginary roots, right? So basically, we have one positive root and two repeated roots at this point, at 0, right? So let's try to think of the graph of this function. So I will write the function here. F of x is equal to f5x squared minus 2x power 5. I will find out the derivative of this. Derivative is 10x minus 10x power 4. So that is equal to negative 10x common. You have x cube minus 1. And basically that can be written as negative 10x, x minus 1, x squared plus x plus 1. So this quantity is always positive. By completing the square, you can see that. So the derivative will change sign depending on the values of 0 and 1. So f dash x is 0 at x is equal to 0 and x is equal to 1. And it will be negative below 0 because this part is negative, this is negative, and this is negative, right? And it will be positive in the middle and negative afterwards. So you can see that the graph is decreasing, then increasing, then decreasing. So 0 is minima and 1 is a maximum. 1 is a local maximum, right? So what is the value of 1? F of 1 is 5 minus 2 equals 3 and f of 0 is 0. So this is a minima, this is a maxima, and the graph is decreasing, increasing, and decreasing. So now we can draw the rough graph here. We have repeated roots at 0 and it was decreasing. So it is like this near 0. Then it rises at 1, it becomes 3 and it is a maxima, right? So it should go down again and cut somewhere like this, right? This point will be 5 by 2 to the power 1 by 3. We saw that there is a root, right? And then it never has any other roots. This is 0, this is 1, this is the value of y is 3 here, right? Now think about it. This is the rough graph of my function. Now we need to intersect this with the line y is equal to k, and we want to have 3 distinct real roots and 2 imaginary roots. So if my y is equal to k is somewhere here, you will see that there is only one intersection, right? But if my y is equal to k is in between 0 and 3, you can see that any such point, there are 3 intersections, right? So basically, k should be between 0 and 3. It should not be equal to 3, because if it is equal to 3, you will have only one intersection here and one intersection here. It should also not be equal to 0. So the possible values of k will be 1 and 2. The integer values of k are only 1 and 2, and that will be the two required values of k for which the whole equation has 3 real roots and 2 imaginary roots. And the main idea of the question is to analyze the question by means of a graph. We looked at the function, we looked at its roots, we looked at the derivative of the function and found where it is going decreasing and where it is increasing and what are the points of local maxima and minimum, right? And that's how we solve this problem. Anytime you have a question based on number of roots, it's a good idea to think of the graph of the function and then proceed, right? Let's move on to problem 99. And this question goes like this. Let f of x be equal to x square minus mod of x minus 2 divided by 2 plus mod of x square plus mod of x minus 6 divided by 2. If L is the number of points where f of x is non-differentiable and m is the number of real solutions of the equation f of x equals to 2, then we have to find L plus m. Okay, so we have to find the values of L and m, and L is the number of points where the function is non-differentiable. So if you have to figure out the number of points of non-differentiability of a function, it will be useful for you if you know the graph of the function. Because if the graph is known, any point where there is a sharp turn, where the slope of the tangent is different from two different sides, is a point of non-differentiability, right? Okay, so let's think about the function and how we can plot the graph of it. So f of x is equal to, we have x square minus gif or minus modulus of x plus 2 by 2 plus mod of x square plus mod of x minus 6 by 2, right? So now, obviously, there is a standard way to do this problem. The standard way is to take cases on x and remove the mod on x, and then take case on the second term here and remove the mod on x again. So there will be one case for x and one case for the overall mod. And you will get basically 3-4 sub cases, and then you will be able to figure out the function easily, right? However, we will take advantage of a nice property and a nice tricky solution. So think about it. This expression x square minus mod x plus 2 can be written as x square minus 4 plus 2 minus mod of x. Think about it. This is obvious. I have not changed anything. I have just written 2 as minus 4 plus 2. And therefore, this divided by 2 is equal to this by 2. And now, similarly, you can write this term also in a similar way. X square plus mod x minus 6 can be written as x square minus 4 minus 2 minus mod of x, right? see, this is still equal to this only, right? So you have x square minus 2 minus of 2 minus mod of x here, and here you have x square minus 2 plus 2 minus mod of x, right? So why is this important for us? So what I have done so far is I have rewritten the function like this. The function is becoming x square minus 4 plus 2 minus mod x by 2 plus mod of x square minus 4 minus 2 minus mod x by 2, right? Now, the thing that happens here is you have two functions, g of x plus h of x by 2 plus mod of g of x minus h of x by 2, right? Here we are saying g of x is basically x square minus 4 and h of x is 2 minus mod x. And that is equal to my f of x, right? So this is the situation that we have. So what is special about this way of writing the function? Now, if you have learned a little bit about maxima, minima type of functions, if you write f of x is equal to max of g of x and h of x, this function can be written as g of x plus h of x by 2 plus mod of g of x minus h of x by 2. Think about why that must be true. If g of x is greater than h of x over some interval x, then obviously the modulus here breaks apart with a positive sign, and you will have g of x minus h of x by 2 from there, and g of x plus h of x by 2 from the other term, and it adds up to g of x. And in case h of x was bigger, then the modulus in the second term will break open with a negative sign, and you will end up getting h of x. So basically, you should learn this, that if you write max of two functions, it can also be written like this: g of x plus h of x by 2, the sum of the two functions by 2, plus the modulus of the difference of the two functions by 2, right? So basically from this, if you understand this, then we can say that here f of x is simply max of g of x and h of x, right? And now that is very easy to plot, for example. So you have understood that f of x is max of x square minus 4 and 2 minus mod x, right? So now what we will do is we'll try to draw the graph of these functions. So this is the rough graph. X square minus 4 would be like this. A parabola which is shifted 4 units down. So this is 0 comma minus 4. And 2 minus mod x would be like this. It will be a straight line type of graph. It intersects at 2 and minus 2, right? So this is minus 2 comma 0 and this is 2 comma 0, and this value is going to be 0 comma 2. Now, if this is the graph of my 2 minus mod x and this is the graph of my x squared minus 4, the max graph, the maximum of the functions looks like this, right? The maximum of the functions is always going to be x squared minus 4 for x less than minus 2, and it is going to be 2 minus mod x for x between minus 2 and 2, and it is going to be again x squared minus 4 when x is greater than 2, right? Now from this graph, it is obvious that this is a point of non-differentiability, this is a point of non-differentiability, and this is a point of non-differentiability, right? The reason is because there are sharp turns in this graph. So the number of points of non-differentiability are 3. So L is equal to 3. And now we also have to check the number of solutions of the equation f of x is equals 2. So if the graph of the function was like this and this point was 0 comma 2, you can draw a line at y is equal to 2 and you can see that there are 3 intersections, right? So there are 3 places where the line y is equal to 2 cuts the graph of my f of x. So the number of solutions is also 3, and therefore L plus M is equal to 6, and that becomes our answer. The main idea in this problem is to avoid doing all the casework and figure out that f of x can be written as gx plus hx by 2 plus mod of gx minus h of x by 2, and that is actually one way to say max of g of x and h of x. If you can figure this out, then drawing the graph of this is super easy, and this solves the problem in a nice and smart way. The other way to do it is also possible, but it will be slightly longer because you will have to take cases like x greater than 0, then cases where the modulus of the second term will be positive or negative, and therefore it will be slightly annoying to do it by the regular method. So that's it for this video. I hope you have understood something from these two problems. If you like the channel content, please subscribe to the channel, share the videos with your friend, and put a like on the video. All your support is super important for me to continue this work. And I'll see you next time.